Okay, so you want to go over just one thing in summary. The last day of class is Tuesday, 4/21. So that, since this is a Tuesday-Thursday class, that is y'all's last day of class. On the last day of class, three things will happen. Okay? Number one, I will enable the Unit 4 test. And the Unit 4 test will cover material, whatever I have assigned for homework, up to the last day of class. So right now, you are responsible today, as of today, you're responsible for 8.1 and 8.2. Now that's till today. And of course today I'm going to try to get into 9. Okay? So I think we're going to at least cover 9.1, 9.2, and I don't know if we'll get into 10 by next Tuesday, but I'm going to try to get into at least 1 or 2 sections. Okay, so, and that test will end on the last day of finals, which is 4/28. So that's the first thing that's going to happen on the last day of class. The second thing that's going to happen is your final exam will start. Your final exam will start on 4/21, and it will end on the last day of finals. So you have 2 tests to take that week. The final exam will consist of probably 33 questions, I think. They're all math questions, and they all come from your old test. So if you want to review your old test, you go to Gradebook, then you go to Test, and then you go to Review. You have 2 attempts and 2 hours to take the final exam. The third thing that will be going on the last day of class, I will be, as a teacher, I will be checking weights and percentages. I will be checking the weight and percentages. I'll also be assigning zeros. Assigning zeros for incomplete assignments. Okay? So that's the 2 things that I'll be doing while you are working on the 2 tests. After you have finished your final exam and your last test and all the homework that you can do, because technically the homework will end on the last day of class. Okay? So your homework is done on the last day of class. After you finish your Unit 4 test, the number of attempts that you're going to try on that one, there'll be 3 attempts. And once you've done with the final exam, you can go to your grade book and hit overall grade. And that is your grade for the semester. Okay, so Ms. McKeon, please verify. Did I go over this Thursday?
Yes, sir.
I think I did. So I went over it 2 days in a row. So therefore, if you send me a question pertaining to this, like if you send me a question that says, Hubert, when's the test due? I'm not going to respond because I've went over it twice. Okay, so I'll leave that on there just for a couple of minutes, and hopefully I'll use it for the next class and I won't have to write it. But that's pretty much it. I'm trying to think of anything else. I think that's it. Okay. Now, last week we did 8.1 and 8.2. And 8.1, basically we talked about the difference between Chapter 8 and Chapter 7. In Chapter 7, the question to the right would have read something like this. Suppose that the mean time for an oil change at blah, blah, blah is 11.4 with a standard deviation of 3.2. What would be the probability of being less than, the time being less than or equal to 11 minutes? Okay, now that was the Chapter 7. So this is what we do in Chapter 7. We would draw a curve and we would do our ritual. And we would 0, 1, 2, 3, -1, -2, -3, 0.15, 2.35, 13.5, 34, 34, 13.5, 2.35, and 0.15. And then we would take, after we, this is our Google drawing that we bring in every single time so we don't have to draw it for the one person in the class that's done that. And then I'm going to put my mean 1.4 right here, and 3.2, it's 11.4, isn't it? Yeah, it's 11.4, sorry. I knew that didn't look right. 11.4, and this is 11.4. So 11.4 plus 3.2 is 14.6. 14.6, 17.8, you have to check me. 17.8, 23rd, 21, please check me. Oh, you're going to have to check me here. Okay, that's going to be 8.2 and 5 and minus 3.2 is 1.8. I don't know if that's right or not. Will you check me, Miss McCann?
I'm working on it.
Okay, good. All right, so we're still doing Chapter 7. We haven't done anything good. We haven't done anything yet in Chapter 8. This is all Chapter 7. And I'm going to take my green marker and I'm going to put 11 right about here. I'm using my empirical rule right now. So there's my 11. And they said a time, I said less than 11 minutes. So that means I want this area right here. Less means left. Okay? So I'm going to change this. If I got an old calculator, I'm going to change this into a z-score by saying minus 11.4 over 3.2. And that's going to be negative 0.4 over 3.2. Do me a favor, Miss McCann, and tell me what is 0.4 divided by 3.2. What do you get? It's going to be negative. I'm not worried about the sign. Just tell me what 0.4 divided by 3.2 is.
0.125.
125. So that z-score for 11 is 0.125. And now I'm going to do 9999, negative 9999 to 0.125. So let's pull up my handy dandy calculator. Hold on a second, I got to pull it up. And the reason I'm going over this one is just to remind y'all what we did last week. And that's 8.1 and 8.2. And 8.2 is really not a big deal. It's just some basic math. But you just got to remember the formulas for Chapter 9. So I'm going to pull up my handy-dandy calculator, which I'm going to drag right here. And I'm going to do clear, and I'm going to do second bars. And I'm going to go to normal CDF. And if I have an older calculator, I'm just going to have to type in negative 9999 and negative 0.125. I know it's going to be less than 50% because I'm on the left side of the 50% line. So I would say probably 48%, somewhere in there. And if you have an older calculator, it's going to look something like that. Except you're not going to have the 0 and 1. It's just going to be negative 9999, comma, negative 0.125, and this hit enter. And that is 0.4503. So my green area in Chapter 7 is 0.4503, which is 45%. Okay, so that's what we did in Chapter 7. So what is different in 8.1? In 8.1, they're going to give you a Part B. And we're going to do Part B in dang old pink.
What number would you go to if you had the newer calculator?
I'm sorry, what?
What number would you go to if you had the newer calculator?
You do the same thing, except you would type in the mean and the standard deviation of 11.4 and 3.2, and you wouldn't have to do the z-score down here. You wouldn't have to see this green calculation. The only reason we did this calculation right here is for an old calculator. Okay? Old calculator, you have to do the z-score. A newer calculator, you just type in the mean and standard deviation, and it will calculate it for you. Okay, 8.1, what's the difference? Well, in 8.1, we add a Part B. And that Part B says, what if? It doesn't actually say what if, but I'm going to use the what if. We had a random sample after we did this. After we did this right here, after we got this, what would happen if we pulled, what if we pulled more samples? Okay, that's what we're adding to Chapter 7. What if we pulled more samples? In this case, we say n is equal to 35. So once we had this information, we say, well, what would happen if we pulled 35 more oil changes? What would the probability be of those oil changes being below 11 minutes? Well, see, the only thing you have to do now is you have to do the same formula, Z formula, except this time, instead of dividing by 3.2, you will divide by 3.2 over the square root of n. So I'm going to do my z-score, my new z-score, is equal to 11 minus 11.4 divided by 3.2 over the square root of 35. And that is what the difference is between Chapter 7.2, I think 7.2 is the best, yeah. 7.2 is actually the section that we did this type of question, okay? So this is the new stuff added, okay? And that new is dividing by the square root, the standard deviation divided by the square root of n. We've added that to our z-score. And when you do that, you get 0.549. 0.549 is your new z-score. 0.5409, which is 0.54. So now we have a z-score of 0.54. So that goes, here's 0.5 right there. So 0.54 is going to be somewhere in there. And now we're going to find that z-score. So it'd be negative 9999 to 0.54. And when you do that, that's what they're doing right here. I'm sorry, divide by 0.54. I'm sorry. I got it mixed up. Oh, shoot. I already drew it. That's not right. Okay, that point here is 0.54. And then you do the z-score, and the new z-score is negative 0.74. My bad. Negative 0.74. That's the new z-score. So this is the area you're finding now. And just remember, I should have remembered this, your random sample z-score will always be less than your regular z-score. Our regular z-score here was negative 0.125. Your new z-score will always be less than that because you're dividing by a bigger number. Okay? So, and that's what we're finding. And if you do the calculation up to negative 0.74, that's going to give you, second, I'm just going to do entry, and I'm just going to go back, and I'm going to change this to negative 0.740 and enter. 0.2296. So our new z-score, our new area is 0.2296. So if we pulled 35 more oil changes, the probability that it'd be less than 11 minutes would be 23%. And that is the difference between Chapter 7 and Chapter 8.1. Okay? And that's the type of question I'm going to ask you on the homework and the test. Okay? I gave y'all 3 examples. I think this is the 3rd example in 8.1. And that's basically the type question I will ask you. Okay? Half of it's going to be Chapter 7, and half of it's going to be this formula right here, right there, and you're going to get a new z-score. And once you get that new z-score, you're going to get a new area that's usually going to be less than your first area, the Chapter 7 area. Okay, that's 8.1. And in 8.2, we brought some new formulas aboard. P hat, Q hat, let's write those down. So in 8.1, we only had one formula, and that is, I'm going to just write it as a new z-score formula. Z new is equal to x minus x bar, not divided by the standard deviation, but divided by the standard deviation over the square root of n. Okay, so that's what you learned in 8.1. In 8.2, we learned a new formula called P hat. And that's x over n. And 1 minus P hat is called Q hat, which is the complement. So if p hat is equal to, let me get this, hold on. If p hat equals 0.58, then q hat is going to be 0.42. Okay, so we learned p hat and q hat, and then we learned the formula for, there we go. We learned for the sampling distribution of p hat. This is kind of like the formula, the formula that we did right here. This is the sampling distribution given the mean and standard deviation. Okay, this is the sample distribution given mean and standard deviation. This is the sample distribution just given a ratio. A proportion. And that proportion is p hat. And if we want to find sigma of the proportion, p hat, that's equal to the square root of pq over n. Okay, so there's the three formulas that we learned in 8.2. Now in your homework, I actually give y'all 8.1 and 8.2 together. It's like 5 or 6 questions. It's not that big a deal. Remember I told you, 8.1 and 8.2 is kind of like getting you ready for chapter 9 and 10. Okay? So here's an example. Sample N, 50, is smaller than 5% of the population. Also, NPQ is equal to 50, blah, blah, blah. Don't forget the little test. We do that test to make sure it's above 10. It's got to be above 10. And then you take the N, that's P hat, Q hat over N. And that is 0.068. Okay? So that's basically, that's an example of a homework question right there, or a test question. Okay, here's an example of a test question also.
Can you bring the other camera forward so I can see the other one?
Yeah,
make sure
this
I have
one.
it.
This one right here.
Yes, sir.
Okay. Make it a little bit smaller so you can see both. There we go. And this is an example of a question. According to the Center of Disease Control and Prevention, 18.8% of schools, okay, that means that's a percentage. Okay, remember that. 6 to 11 years old were overweight in 2004. In a random sample of 90 school-aged children aged 6 to 11 years, what is the probability that at least 19% are overweight? Suppose a random sample of 90 school children, that's the part A, that's 90, that's new N right there, age 6 to 11 years, result in 24%, blah, blah, blah. You finished with this over here?
Yes, sir.
Okay. Well, the first thing you're going to do is pick out your information. So I'm going to kind of make this a little bit bigger and let you write that question down. Now we know that N is equal to 50 because it's bigger, N is equal to 90 because it is the biggest number. We know that. Let me know when you finish writing that one down.
I took a picture and I'll write it down later.
Okay. So here's the information. N is equal to 90. And we know with N is equal to 90, we put it in that MPQ formula. And of course, 13.7 is greater than 10. Okay, so it's doable. And now we're going to do the standard deviation. Okay? And we know that p hat is 0.188 because that's given. So in this formula, I'm just going to write this down and bring this up. Well, let me see if I can make this a little bit smaller. That's as small as I can make that, I think. Yeah. Yeah, as small as I can make it. Let's see if I can move this over. Give me a second. So we know that p hat, and I'm going to write this down. We know that p hat is equal to 0.188. Therefore, q hat is equal to what? 812. Check me on that. Take 0.188 away from 1. We know that n is equal to 90. And we got some other things in there and we got a 24 and we got a 19. And that's going to come in later. Is that 0.812 correct?
Yes, sir.
And of course, take that NPQ, N times P times Q, and that's got to be greater than or equal to 10. And of course it is, so that checks. And then we get the standard deviation of the sample distribution, which is the square root of PQ over N, which is equal to square root of 0.188 times 0.812 over 90. And that comes out to be 0.0412. And now we just go back to chapter 7 or 8.1. Now we're just going to figure a new z-score. And it says in a random sample, 19%. So that's going to be our new z-score. A is z at 19% is equal to 0.19 minus 0.188 over 0.0412. Well, here, why didn't we use the square root of n, or why didn't we use the standard deviation over the square root of n? That's not given. Okay? If you remember on the previous question, what was given in the original question? The mean and the what? The standard deviation. In this question, the mean and the standard deviation is not given. What's the only thing given? P hat and what? N. So it's a difference in the question. The question in the first one was mean and standard deviation was given. The second one, the P hat and N was given, and you got to find Q hat, and then they give you some more material than A and B. And that's equal 0.0485. Remember the nickel rule? I told you the nickel rule. I don't know how to spell nickel. The nickel rule, I can't remember if it's E-L or L-E. Tell me if it's which one it is. Nickel rule says if your probability is greater than 5 cents, if your probability is greater than 5 cents, then it's normal. If it's less than 5 cents, it's unusual. Okay, that's my nickel rule. I told you, is that spelled nickel as L-E or E-L? I'm going to look it up. I'm not a speller, so half the time I get it right because my brain tells me and I don't talk my brain out of it.
I'm pretty sure it's E-L.
C-H-E-L. Nickel. Yep, that's right. All right, so in this case, my brain was telling me it's right, and I didn't tell my brain that it was wrong. Usually I do, but sometimes I don't. All right, so is this one less than or more than a nickel? Technically, it's less than a nickel. So therefore, it's unusual, okay? But we're going to go ahead and it says P0 is equal to 1 minus 0.5199. Now, where did that 5199 come from? Well, okay, they're calling that z-score 0.05, so that's what they're saying. They're saying that that's equal to 0.05. So they're going to the z-score and they're saying greater than 0.05, so that's going to be do 0.05 to 9999 normal CDF. Would you do that for me, please? That's a z-score. Yeah, I don't know what I was doing there. Okay, forget that. So z-score is equal to 0.05. So do from 0.05 to 9999. What do you get? Should be 0.4801.
I was in the wrong thing. Give me a second.
Oh, that's fine. I'll just hit second entry. And I'm going to change my bottom one to 0.0500. And the only reason I'm putting all that in so I don't have to delete anything. And 9999.
I got 0.48006.
Yeah. Should be 0.4801.
Yes, sir.
And that's equal 0.4801. And the reason we're going to the right is they're wanting to know, look at the question. The question says A, at least 19%. At least 19% means 19 is the lowest number, so you're looking at 19 or greater. So you're looking on the right-hand side, and that 19% z-score comes out to be 0.05. Now let's do B. B, suppose a random sample, here's where we get into the 8.1 material, okay? Suppose a random sample of 90 school children aged 6 to 11, we don't care about the 6 to 11, results in 24 overweight children. That's a new, we got a new rate here. What might you conclude? Okay, so now our new p-hat, because we're not given a mean and a standard deviation, we're given p-hat. So if they give us a new p-hat, then we're going to do new p-hat. So B is going to do, I'm going to do a new p-hat. So p-hat is equal to 24 over 90. which is equal to 0.2667. So now I've got a new percentage. That's my new percentage. My new percentage, or my new proportion. So now I'm going to take that one, 0.2667, and do a new z-score, minus 0.188 over 0.0412, and that's going to give me a new z-score of 1.91. And we want to know what's the percentage of students above 24. So our results in 24 overweight children. Okay, and that's going to be it's going to be from 1.91, comma, normal CDF, 1.91 to 9999, and that comes out to be 0.0281. So again, 8.2 is nothing but a couple of formulas that you use when you're not given the mean and the standard deviation. Okay, so let me go over that again. In 8.1, you're going to be given the mean and the standard deviation, and you're going to use a new random sample, which is equal to n, and you're going to conduct you're going to find a new standard deviation or a new z-score by using x minus x bar over the standard deviation divided by the square root of n. So that's 8.1. In 8.2, you're not going to be given a mean and a standard deviation. You're going to be given a proportion. And that proportion could be given to you as x over n, or it could be given to you as a percentage or a decimal. Oops, sorry. And if you use, what is all that? I'll have to look at, I didn't know I could, slow motion, live, time lapse, Twain, I don't know what Twain is. Okay. If you are given a proportion, that means p hat. It could be given to you as x over n, or a decimal, or a percentage. Then you're going to use 1 minus p hat, and that's going to be equal to q hat. And you're going to use the square root of, your new standard deviation is equal to the square root of p hat q hat over n. And then you could use your new z-score using and they may ask you to use the z-score, which we just did in that D right there. You could use that z-score formula, the regular z-score formula of z is equal to old, which is equal to x minus x bar over standard deviation. So, well, you could put a new here. Yeah, new standard deviation of 0.04 that you found in A. So that's basically 8.1 and 8.2. So anything preceding to a question on 8.1 and 8.2 on the test will come from these two formulas and the two examples that we've done. 2 or 3 examples that we've done. Now, 9. This is where we start getting into estimating the hypothesis and all that, or we're starting. Okay, now they're calling it a point estimate. Now, is there a difference between p hat and point estimate? No, they're using the same. They're just calling it something different. So write that down. A point estimate is the value of a statistic that estimates the value of a parameter. For example, the point estimate for the population proportion is p hat. So you don't have to write that word for word, but you can write it down. Point estimate. They may give you a point estimate of p hat. They may give you a point estimate of something else. But in this case, it's going to be p hat, where x is x over n. And we've already done one like this. In July, a Quinnipiac University poll asked 1,783 registered voters. You know, I forgot to do something. Please tell me I hit record. I can't find my... Oh, yes, I did. And I don't know why I'm playing my video. I need to shut that off. 1123 were in favor out of 1783. Well, boom. P hat is equal to 1123 over 1783. Boom. That's it. That's what p hat is. And if you need a decimal for that, the decimal will probably be on the next slide, so I'm not going to do it. There you go, 0.63. Therefore, Q hat is equal to 1 minus 0.63, which is equal to 0.37. And that should be a given. Anytime you find P hat, the first thing you need to find after that is Q hat. A confidence interval. Now this is where we get into something that you might want to put on a index card. Okay? Confidence interval. Now, let me just get to it so I can... 95% confidence. Okay. This is how we're going to do a confidence interval. And I tell my students to do this and put it on an index card. And for the test, you're going to need it. Let's say that this piece of notebook paper or this piece of printer paper is your index card. You need to divide it up into several columns. And a header. This right here is going to be your confidence level. Now the confidence level is going to be a percentage. And it's going to have the word confidence level beside it. I'm going to start mine at 95. And I'm going to go to 96. And 97. 98. And 99. Now why didn't I go to 100? Because nobody is what? Perfect. And the chances of us getting a 100% confidence level, I'm going to put 100 up here, but I'm going to put a red X through it because Is that obtainable? No. 100% confidence level is not obtainable. That's like saying that the work that you're doing is perfect. Okay? Now, why didn't I go below 95%? Well, if you're being paid to do statistics, you don't need anything below 95% because you don't want to turn in anything less than 95%. But I'm going to write down some more problems. I'll do this in a green. I'm going to put 94, 93, and I would carry it down to maybe 90. Okay, because the homework questions, they do ask some lesser confidence intervals. So you might want to make this go from 90% up to 99% for your homework. Okay? Now, what's the next column? The next column is called alpha. Alpha is a backwards looking fish. Okay? And alpha for 99% would be 0.01 because this is 0.99. Okay? So that's going to be 0.01. 98 is 0.02. 97 is 0.03. 96 is 0.04. 95 is 0.05. 94 is 0.06. 93 is 0.07 ... 0.10. The next column is going to be called alpha over 2. 1 cent divided by 2 is 0.005. 2 cent divided by 2 is 0.01. 3 cent divided by 0.015. 4 cent divided by 2 is 2 cent. 5 cent is 0.025. 6 cent is 0.3. Y'all see a pattern? ... 0.05. Half of a dime is a nickel. Now the next column is going to be called Z sub alpha over 2. And most of the time we're going to be using the positive, the absolute value of this. We're not going to be dealing with the negatives. Okay? So we need to plug in, these are areas, so I'm going to add a 0 here, a 0 here, and a 0 here, a 0 here, 2 zeros here, and so on. So that means with Z sub alpha over 2, I've got to use my inverse norm. I've got to use inverse norm for my alpha over 2. So take your handy dandy calculator. Okay. Oh, that's not the right calculator. That's on my phone. Sorry. And second bars, inverse norm. And your first one is 0.0050. And we're going to go with the left tail. That gives us negative 2.58. So 2.58. Okay, let's go back. Second entry. Now I'm going to type in 0.0100. Negative 2.33. 2.33. And so on. Second entry. 0.0150. 2.17. Second bars, or second enter. 0.200. 2.05. Second entry. 0.250. Negative 1.96 or 1.96. Zero 300. Negative 1.88. Negative 0.035. Negative or 1.81. And I'm going to carry it all the way down, and you can do the others. This will be 0.0500. 1.6. You could argue 5. I'm going to put 1.65. And that is pretty much your, this is what your card should, like always leave an extra column or two just in case. We'll might fill something in there later. And that's what they're going to tell you to do in these next few slides. Okay? Now let's talk about point estimate. Plus or minus the margin of error. We're going to call that MO. Okay? Margin of error, we're going to call it MO. So a confidence interval, and this is what a homework question or a test question will ask you. Find the confidence interval based on the confidence level. Based on confidence level. Now you need to make sure you understand the difference between the two. A confidence level is something that you state. I'm 95% confident. That's a confidence level. Okay? A confidence level is usually stated in the question. And it usually says a 95%. One of the most popular ones used is 95% confidence level. Okay? The confidence interval is what you calculate to reference the confidence level. Okay, so if I say, well, Hubert, you're 95% confident, I want you to calculate me a confidence interval. Okay, and that confidence interval is always going to be your point estimate, whatever you're using, plus or minus the margin of error, the MO. Okay, and this will make sense after we do a couple of problems. So if I have a point estimate of 0.05, this is an example, plus or minus a margin of error of 3%, then that means my confidence interval, P hat, is going to be between, what is 5 cents less than 3 cents? 2 cents. And my plus 5 cents plus 3 cents. 8 cents. This right here is called the confidence interval. That's called the confidence interval based on 95% confidence level. Okay, so that's what we're going to be doing in 9.1. Okay, and I will go ahead and tell you we are getting into test questions. In 9.1, that's where we get into test questions. We may have a couple of questions on 8.1 and 8.2, but a bulk of your test questions are going to come from 9 and 10. I would say 80% of your test questions are going to come from Chapter 9 and Chapter 10. Okay? Now, if we don't get to Chapter 10, then 80% is going to come from Chapter 9, 9.1 and 9.2. Okay? So, we have just found, this is an example. Now, we didn't calculate it, but this is what it looks like. Okay, this is what a confidence interval looks like. We didn't calculate it. Okay? And this based on a 95% confidence level. Now, if your confidence level changes, your confidence interval is going to change. Okay? And that's what they're fixing to tell you probably in the next problem. Okay. Okay. Level of confidence. We just talked about that. As the confidence level increases, the margin of error also increases. Sample size. As the size of the random sample increases, the margin of error decreases. And that's the law of large numbers. Standard deviation of the population. The more spread there is in the population, the wider our interval will be. Remember, I told you, standard deviation is what? Spread. I told you that the first couple of weeks of class. All right? So write those down. Level of confidence. As the level of confidence increases, as the confidence level increases, the margin of error also increases. Sample size. As the size of a random sample increases, the margin of error decreases. That's the law of large numbers. The more spread there is in the population, the wider, more spread means wider, our interval will be for a given level of confidence. Now they're going to give us, there's our definition, there's our first formula. For a simple random sample of size n, the sample distribution of p hat is approximately normal with the mean m sub p hat, or mu sub p hat is equal to p, and the standard deviation of p hat is pq over n, provided that MPQ is over 10, and we talked about that in 8. Okay? There's the nickel rule also. And we just talked about this. Okay, I'm not going to go over that again. And here we go. Here's our first formula in 9.1. That's important. And really, we don't, okay, I'm not going to do the P minus yet, the P plus, so don't write that. I want you to write confidence interval is Z, or you could put P hat, confidence interval, I'll write it down. I don't really like doing the P in there. I don't like doing it that way. Let's just go with margin of error. Yeah, pretty much, because you're subtracting the n. So margin of error is equal to Z sub alpha over 2. That's the index card we just made. Okay. Square root of P hat Q hat over n, which you got that out of, where did we get that? Was that 8.2? And then I'll show you how to do the confidence interval. This is showing you, this right here on this slide is showing you the confidence interval. I don't want to do that. I want to show you that after we do the margin of error. I want to do it. That's the way I teach it. And I do realize that we are at 9:09. Class ends at like 9:20, doesn't it, or 9:15? Which one is it? 9:25? When does class end, Miss McCann?
I think it's 9:20.
9:25 or 9:20, somewhere. I think it's 9:25.
Yes. It
Okay.
might be 9:25.
Well, it ain't like you or I going anywhere, so. And the one person that watches this video, he or she's not going to go anywhere, so. All right, so let's move on to the next slide so we can get to a example. And there's the margin of error there. Okay, that's what I just did. So they did. I don't like this slide. I like this slide. Okay, so the margin of error of the mode is equal to z sub alpha over 2 square root of pq over n. And it'll make a whole lot more sense when we get to an example. Okay, here is an example, and this is taken off of the first thing that we did, except it added a statement. So in July, blah, 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 we got 1123 over 1783. So p hat is equal to 1123 over 1783. And we did have a, hold on, that's 0.63. Therefore, Q hat is equal to 0.37. And now they say, right here, obtain a 90% confidence interval. At that point, what do? You go to your handy-dandy index card, and your 90% confidence level gives you a z-score of 1.65. 90% confidence level gives us, through the index card, a z-score of 1.65. That's why you need this index card. Now, you can do it individually, okay? It's supposed to. There. You can do this individually on a case-by-case basis, but it sure does help out to have an index card with all 90 to 99. Okay? So, let's find NPQ, and it's above, it's way above it. So, NPQ is going to be way above, is above 10. I think it comes out to be what, 415? 415.6 is way above 10. So this problem is good to go. Oh my gosh, look at there. What they got? 1.65. What did we get? We got 1.65. So that means that our index card works. If you want to change your 1.65, since the book is using 1.645, if you want to change yours on your index card, change it, but it's not going to make that big a difference. Okay? So now I've got my 1.645, so I'm going to find my margin of error. My z-score is 1.65 times the square root of PQ over N. And N is 1783. And you crank that out. So I didn't do it the way they did, so I'm going to do it by hand. Okay, so let me pull up my handy-dandy calculator. And I'm going to show you, I'm not doing the lower bound. So I'm mark that 0.63 out, okay? We're not doing that. We're not, mark that negative out, mark that positive. We're doing the margin of error. I think it's better that you understand what the margin of error is first. So 0.63 times 0.37 equals, divided by 1783, and multiply or raise that to the 0.5 power. Take the square root of it. And then multiply that by 1.65. They use 4.5, so we're going to use 4.5. 0.0188. I'm going to write that down. So my margin of error is 0.0188, which if you're talking about 1%, 2%, this is a 2% margin of error. In statistics, a 2% margin of error is good. Anything above 3% is not worth anything. Okay? 2% is a good margin of error. And now I'm going to make my confidence interval. So I've got my, oops, I'm sorry. I left that out. There we go. So I've got a 0.0188, and then confidence intervals, margin of error is usually to the whole percent. So that's why I did 0.02, which is equal to 2% margin of error. So that means I've got to add 2%, 0.02, that's 2 cents. I've got to add 2 cents on one side, and I've got to subtract 2 cents. So my p hat is 0.63. Okay, so what is 0.63 plus 2 cents? That'd be 65 cents. What is 63 cents minus 2 cents? 61 cents. So there is my margin, my confidence interval. And if you look what they got 0.61 and 0.65. This is my confidence interval based confidence interval
Priority 1 message coming in on secured channel.
On a 90% confidence level. So if I ask you a question out of chapter 9, this is going to be the first one. Okay? And they gave us this. And they gave us this. They gave us those two things. And they wanted a margin of error. That's the questions I like asking. Find the margin of error or find the confidence interval. And let me just make a note. This 0.02 right here that 0.02 is right here and right here, because what do you do on the right side? You add on the right side. What do you do on the left side? You subtract. And that gives us an area of 61 cents to 65 cents, or 61% to 65% is the confidence interval based on a 90% confidence level. So if your p hat hits within 61% or 65%, then you are in the confidence interval. And I got a couple of more minutes, so let's see what the next slide gives us. Should give us N, how to find N. Okay, we are 90% confident it'll fall between 61% and 65%, whatever they're talking about. There we go. And write this down. N, and this is how you find your survey size. How do you find your survey size? Oops. And I write down survey size because that makes sense. If you're trying to figure out how many people to survey based on a confidence level, survey size based on a confidence level. In other words, if I want to be 95% sure of my statistics, I need to have a survey size based on the confidence level. So I've got to find the number of people to survey to get a 95% confidence level or 98% confidence level. So P hat, Q hat, Z sub alpha over 2, which is your index card, over the margin of error. And remember, this is your index card. This is your margin of error. And this is going to be given, P hat is going to be given, and the confidence level is going to be given. Okay, so the two things that are given will be P hat in some form and the confidence level and probably the margin of error, unless they did give you a two-part question to where you find the margin of error. So your first question will be find the confidence interval and the margin of error. Okay, that's the first one, or the margin of error and the confidence interval based on the margin of error. And then the second question you'll have in 9.1 is finding N. Finding the survey size based on the confidence level. And these are pretty easy. So let's do one. Use an estimate of P hat based on a solid study, point P 0.5, largest possible value N. Okay, what? Oh, I know what they're doing here. They're fixing to give you 0.25. If you're not given P hat, what do you use? You use 0.5 and 0.5. Okay. You need to make a note of that. If you're not given P hat, okay, and I'm going to write this down here. I like to write it differently. If I could hit the right button. Okay. If not given P hat, then use N is equal to 0.5 times 0.5, which is equal to 0.25 times Z sub alpha over 2 over margin of error squared. Okay, that's what they're telling you to use. Let me ask you this. If you're not given P hat, then you go from it's either right or wrong. It's either sick or not sick. It's either true or false. What's the probability of heads? 0.5. Then what's the probability of tails? 0.5. What's the probability of true? 0.5. What's the probability of false? 0.5. What's the probability of sick? 0.5. What's the probability of not sick? 0.5. So if you've got P given, that's great. If it's got P hat not given, then you're thinking along the lines of true false, which would be 0.5 times 0.5, which is equal to what? 0.25. So this would be the formula you use if P hat is not given. And then you would use this formula if P hat is given. And you might see one of each in the homework and on the test. Here you go. A sociologist, okay, wanted to determine the percentage of residents of Americans that speak English at home. What size sample, N, write that down, find N, should be obtained within 3 percentage points, that's the mode. So in this problem, let's write down what we're given. So I know that we're going to find N because the question asked, it said find the survey size. We know that MO is equal to 3. We know that confidence level is equal to 90. Therefore, we've got a 1Z is equal to 1.645, and that's given by our index card. And let's see if anything else is given. She uses estimated attained supplementary of 82.4%. Oh, that's p hat. I didn't know they usually put p hat first. P hat is equal to 0.824, therefore Q hat is equal to 0.176, maybe. And that's what they're going to write down on the next slide. Oh yeah, you got to change that. 3% is equal to 0.03. And that's it. So now you just plug and chug. My 1.645, that's going to be the z-score. There it is. And then you take PQ. So let's go plug everything in. PQ. So my N is equal to P, Q, and then my 1.645 over 0.03 raised to the second power. And that comes out to be 436.04. Let me go ahead and tell you that no matter what this is, you're going to round up. Because what did I tell you about the law of large numbers? You always want to go with a bigger number. Here is not where you say, well, 436.04, I'm going to pull 436 people. No, actually you should pull 500. But the number is calling for 437. But I would not tell any of my students, if I was teaching a research class, I would say, you're not going to pull 437. You're going to pull 500 people, at least. Because you always want to cover your backside. Okay? And that's the 2 questions you're going to get out of 9.1. And look, next slide is 9.2. So that's the only 2 questions you're going to get. You're going to find the confidence interval given a confidence level, or a margin of error given a confidence level, and you're going to be finding N. There's 3 very, very important test questions right there. Okay, we're going to have to shut her down because my students are already Skyping.